A stone is dropped from a roof of a building and hits the ground at a velocity of negative 135 feet per second. We want to find the height of the building. So we have this picture here. Here's the building, here's the ground. Okay, so we have some person standing up on the roof. There's a rock, and the person just reaches out and drops the rock. So it comes down like this. Now, because it's starting from a stopped position, the person doesn't throw the rock off. He just reaches out and lets it fall. So because of that, we know that the initial velocity is going to be 0 feet per second. So even though the problem didn't directly tell us that, we can determine that. And then when it hits the ground, the problem does tell us that the velocity when the rock hits the ground is negative 135 feet per second. Now we don't know the time it takes for it to hit the ground, so I'm going to label that as TG for time it takes to hit the ground. And when it does, that's going to be negative 135 feet per second. And it's negative because it's falling. Okay, now, one more thing that we need that the question doesn't directly tell us, but we know that the acceleration due to gravity is negative 32 feet per second squared. All right, so we're going to use the idea of the antiderivative to find the height function, because the idea of this question is we want to find the height of the building. So we want to find the initial value of the rock, how high it was when it started. So we're going to start with acceleration and work backwards, and I'm going to find the velocity. So if I find the antiderivative of negative 32, that's going to give me negative 32t, and then plus our constant. We can use the fact that we know that if I plug in 0, I should get out 0 because the initial velocity is 0. So if I plug in 0 for time and 0 for the velocity, I'm going to get that the constant is 0. So my specific velocity function, it's not the family of functions, but the specific one that will give me initial value of 0 is just negative 32t. Okay, now I'm going to work backwards again and take the antiderivative. So now I'm looking for my height function. When I take the antiderivative of negative 32t, I get negative 32t squared over 2, and then plus my constant. And then when I simplify that just a little bit, I get h of t is equal to negative 16 t squared plus the constant. Now, this constant right here is a little bit tricky because we're really not given any information about the height function so that we can plug in something for t and the function h to solve for c. So what I'm going to do is I am going to say, let's let this green mark right here at the height of the building be h of 0. Let that be 0. So I'm going to call this mark right here where I just made that green line, this is going to be our x-axis, which means when we find the height here, this is going to be negative because it's below the x-axis. But by starting it here and making that line and making an assumption that we're starting at 0, the height will be 0, then that constant is going to be 0. If our initial value is 0, that means we're plugging in 0 for t, 0 for h, so our constant will be 0. So making that assumption that h of 0 is equal to 0 gives us that C is equal to 0. So now that gives us our height function is just negative 16t squared. Gotta give myself some more room here. Hold on. Negative 16t squared. Okay, so now in order to find the height, if this is at 0 right here, then I need to find this distance, what the height is, when the rock hits the ground. That will give me this height. So I need to find the height of the time when the rock hits the ground, which means I need to find that value of TG. And I do have enough information to find that. I can use the information that the problem gave me, that when the rock hits the ground, it's at a velocity of negative 135. So I'm going to do a little bit more work up here. I'm going to have that, here's my velocity function. If I plug in TG, so I'm trying to find that height, or I'm sorry, I'm trying to find the seconds when it hits the ground. That's negative 32 TG, and I know when it hits the ground it's negative 135. So if I solve for TG, I'm going to get 4.21875 seconds. So the time it takes for it to drop and hit the ground is 4.21875 seconds. Now that we have the time that it takes to hit the ground, I can plug that into my height function and say if I plug in 4.21875 seconds into negative 16t squared, I'm going to get that my height is negative 284.75, nope, that's 765. 765,625. Now, we anticipated that this was going to come out negative because of the way that we set up the problem. We set up the problem so h equals 0 is at the roof. So when it falls and it goes below that, that border, or that, if we imagine that that's the x-axis, when it hits the ground, that distance is going to be negative because it's below. So that's why we have a negative for the height. But the height is actually just 284.765625 feet. The negative only indicates that it's below where we have it set up as the height is 0. So the height of the roof, the final answer would be 284 and then 0.765625, and then just depending on how you want to round it, just make sure you follow the rounding directions.